Okay, so this is lesson 3 of methods. So in this lesson, I'll cover the final topics, which is how to pass by value, like what the difference between pass by value and pass by reference is, as well as how to return values out of a method. So to start off, this is a bit of a tricky one. Explaining the difference between passing by value and passing by reference. So when you pass in the round brackets something to a method, it can use it in different ways, and it's automatically determined in Java by the type of data you give it. So in this slide, it says Java arguments are passed by value or by reference, depending on their type. So the primitive data types like int, double, char, boolean, those ones are all passed by value, meaning it copies the value from that calling statement when you call the method from that variable into the parameter for the method. So it kind of copies that value along, but you don't have a direct link to the original one. So passing by reference is the opposite of that. It happens when you pass an object. So if you give a method an object, it's going to have the memory address so it can reference back to the original one and link back to it and modify it in any way you want. So let's take a look at some examples. Hopefully that'll clear it up a bit. Okay, so before I get to that, let's go to Eclipse. Okay, so here's an example I made just for pass by value. So you notice that this is an integer called num. I set it to 2. Then I pass it to this double it method as a parameter. So because these have the same name, the variable here and the variable here, it is a little bit confusing, but you have to remember the rule is if you make a variable within a set of curly brackets, it's only available within that set of curly brackets. So this num here, when I click on it, it highlights all its occurrences. So it occurs 3 times here, but it doesn't highlight these ones because this, although it's the same name, it's actually a completely different variable. So this is a parameter. It's not, it is a variable, but it's not independently constructed there. So it's kind of part of the header here. So this parameter is referenced here only. So these have totally different scopes. And because they're primitive data types, int and int, when it runs this method here, it passes the number 2, which is what it was initialized, and initializes this parameter's value to 2. So when you multiply it by 2 to double it and assign it back, the value of num here locally is actually 4, but when control returns back to the statement following where we called it here, and we go to print out num, it's going to print out at 2 because that's this local variable's value. And even though it did this doubling here, it didn't affect the one up here because it just copied the value into the method. So there's no link between those two. So that's what happens with primitive data types. Passing by reference, this example, I'm going to try to make some objects here. So I'm making this string buffer, which is kind of like a string. I'm also making a string, and I'm also making something called an array, which is a list of, in this case, integers. And I'm going to try passing all 3 of those into different methods and see what happens to them. So passing by reference means that the method should have a link, a memory reference back to these objects and should be able to change them in some way. And so when I print them back out in the main method, like I go to print name, it should have, through this change name method, should have been able to modify name. And in the case of the string buffer here, I'm going to add adds an A at the front of it. So we'll see if when it prints out, it adds an A to the front of this name. Same with this integer array. I'm going to pass the integer array. The name is not a good name, it's X, but anyways, I pass that array called x into a method called changeArray. And changeArray is going to change the first element in the array. I know we haven't really covered arrays yet, but hopefully you'll get the idea. So these are all objects, right? They're not primitive data types. It starts with a capital S, that's why string buffer is a class, and SB would be an object of that class. String is a capital S, so name is actually an object of type string. And although this one looks weird, this looks like it's a primitive data type, int, right? But it's actually an array of ints. So the square brackets here, they'll look like a box. That means it's a list of integers. So this object x is actually an object of an array. So these all should work, right? So let's take a look at the first one. So I'm gonna run change name on name, which is Daniel, the string. And so I run that. Change name should take that string. The parameter is called s, so it sets s to Bobby instead of Daniel. So if I come back here and I print out name, it should print Bobby. It should have changed it from Daniel to Bobby. Just so we don't see the answers of the other ones, I'm going to control / those ones out, and we can run it and see what happens. So it prints out Daniel still. Now that's contrary to what I was saying. So I put some comments here, but really the problem here is strings are actually immutable. So it's kind of a bad example. So although it is passed by reference, the reference when you change a string always gets thrown away anyways and given a new reference. So this is a bad example. But I like to do it just to show you that it would work with other objects. It's just kind of an anomaly. So that's why string buffer is pretty much the same thing as a string, but it's actually a mutable thing, right? So here with Mickey, we can change it. And so SB is my string buffer. I'm going to pass it into my method, and I am going to print SB afterwards, and it should have an A in front of the M if all goes well. So let's take a look at, just by the way, how that works. So you can see my parameter here is a string buffer type, which is an object. Well, it's class, so this S is an object of type string buffer. And I just say s.insert, so I run the insert method, which at position 0, which is the very beginning, inserts the character A. So, but because this S actually points to the original string buffer that I made here, it can actually modify it. So this time it should actually change. Yeah, there we go. So put an A in front of Mickey. So that one worked. And for my array, I'm going to output just the first element of the array, just because it's easier. And we can see that it is a 1 right now at the first element of the array, of my array x. And when I pass it to changeArray method, pass x there, you can see this is an integer array called x. So the names are the same here, but they don't have to be, as we saw in the last example. But this time it should, still going to print out the other one. So I told it to change it to a 10, and when it printed out the array element 0, the first one, it printed out a 10 instead of what it originally was, which was a 1. So I just demonstrated that by passing by reference, it can link back to the original thing, object, and change it in some way. So it's handy to know that. You can use that to your advantage, or it could kind of mess you up if you're not expecting it to do that. So it's good to understand that. It is a bit of a trickier concept though. So going back to here, so the return statement is a way that you can send things back out of your method. So it's kind of like the third step. The first thing we did was things that were void, didn't return anything and didn't take any parameters. The second lesson talked about parameters. but they were all still void methods. Now we're going to return something. So it's very handy a lot of the times to send a value back to the statement that called the method. So for example, math.pow, if you give it parameters like 2 and 3, it'll pass you back 2 to the power of 3, which is 8. Then you can do that, you can use that in some calculation, right? So the rule is that it can only ever return one value, because in your method header, you can only specify one thing, void or int or double or whatever it returns. So in this case, you can return a double, but you can't return a double and an integer, for example. So in the method header, you have to specify what type. So instead of void, I'm putting double here, and it's going to do the cube of some number x. So I pass it in x. Inside, it multiplies it 3 times, gives me back the result. So when I call it, since it returns something, the difference here is I call the method, give it a value, and then since it's returning something to me, I got to go back and have a variable that's going to catch that. And of course, since this returns a double, then this variable here called cube must be a double so that it can accept the value that gets passed back. So if we look at the first program that we did in this chapter, it was converting Fahrenheit to Celsius and Celsius to Fahrenheit. So another way to write that method would have been, and I think this is a better way to actually do it, a bit more flexible, because I can now use the returned value in something. But we could have made it into a method that accepts a parameter. So you can see it has a parameter coming in before it was empty. And it's not void anymore, it returns a number back. I just decided to use integer values because we rarely ever talk about, today is, the temperature is 21.6. We just say integer values. So I just made the call. You could have easily made this a double and a double. No problem. It would have been a good call as well. So here I'm just in the main now. I'm doing all the make the scanner, make my variables, ask for the value, get the value, and then I pass the value of the Fahrenheit temperature into my method. At this point, it goes down, starts initializing this local parameter that exists between these curly brackets. It makes a temporary local variable called ctemp, and it does the calculation required, and then it returns the Celsius temperature. So you can see here, I've caught that variable. I've caught the value that gets returned in a variable of the appropriate type, integer, and then I can just print it out. So that's another way to handle that initial question of conversions. And like I say, this is a bit better because you can pass it a number, it passes you back the Celsius conversion, and you could then use that in further calculations of something else. So whereas in the first example, the method itself asked you for the temperature and printed something, printed the conversion, which is not flexible. I couldn't then reuse that calculated value. Okay, so you might be saying, well, returning one value is kind of limiting, but here's a way around it. So in this program, it's giving me this Pythagorean triple. This is actually something out of the textbook. So I pass it a couple numbers and make some calculations, but I need 3 things returned back. So what you could do is you could make an integer array called ABC, and here's my 3 calculated values. I populate the array. We'll cover arrays later, but it just returns a reference to that array. And this says it's going to return not just one integer, it's going to be an array of integers because of the square brackets there. So that way I'm kind of still returning one thing, but that one thing is an array that contains multiple things. And I can also return other classes that can contain multiple things. So that is the end. I think I've covered pretty much everything you need to know to use methods, and you can go ahead and practice these.